Earlier code has given various classes, but now it is not there. Do you have a copy of the code book with you?
Yes, sir.
What is the year?
2015, sir.
Okay, good. All these are the power lines. These things I explained in the previous class. Let us solve an example. From that, I'll explain various classes. An industrial structure. An industrial structure having a maximum dimension of 65 meters. Is proposed to build on downhill side near Chennai. The height of the hill is 350 meters. The height of the hill is 350 meters with a slope of 1 in 5. If the location is 200 meters, from the crest of the hill, on the downward slope, and its eave board is at a height of 15 meters. The height of 15 meters. Determine the design wind pressure. Determine the design wind pressure. Spacing of truss is 5 meters. And the span of the truss is 20 meters. It is there somewhere here, this structure. And just I am repeating that question again. An industrial structure having a maximum dimension of 65 meters is proposed to be built on downhill side near Chennai. The height of the hill is 350 meters with a slope of 1 in 5. If the location is 200 meters from the crest of the hill on the downward slope and its eave board is at a height of 15 meters. Determine the design wind pressure. Determine the design wind pressure. Spacing of truss is equal to 5 meters. Span of the truss is equal to 20 meters. Okay, this is the data that is being given to us. What he is asking us is to find out the design wind pressure. Design wind pressure is how much? That is given by PD is given by Ka, Kc, Kd into Pz. Design wind speed, where Pz is equal to 0.6 Vz square. I am using all the notations given by this code, where Vz is equal to Vb into K1, K2, K3, K4. Earlier code did not give this K4. Okay, this is what is to be found. In a nutshell, I am telling you, this you have to find out PD, design wind pressure, that is given by Ka, Kd, Kc, Kd into Pz. Pz is equal to 0.6 Vz square, Vz is equal to Vb into K1, K2, K3, K4. We have to see what is K1, K2, K3. Then Vb depends on the city. See, look at this. This is the basic wind speed. In the previous class, I hope I explained these things. Hello, Baba.
Yes, sir.
Yeah. Please look at figure 1 or NXA of what is the basic wind speed for Chennai? Babu, unnara leda? Had dinner or not?
50 meter per second.
50 meters per second. It is approximately equal to 180 kmph. We convert that to kilometers per hour. Risk coefficient K1. Return period, that is probable life of that in that what is the probable value maximum wind speed in a particular period. If you expect the building to be there for 50 years, what is the maximum speed that is likely to occur? If you expect the building to be there for 100 years, what is the maximum speed that is likely to occur in that? That has to be taken into consideration. Look at the class 6.3.1. Go to the page 5 and table 1. See, this is a formula given by the code. K1 probability factor risk coefficient, K2 terrain roughness, K3 topography factor, K4 is importance factor for the cyclonic region. You see this risk coefficient. Figure 1 gives the basic wind speeds for terrain category 2 as applicable at 10 meters above the ground level based on a 50 years mean return period. The suggested life period to be assumed in the design and the corresponding K1 factors for different class of structure for the purpose of design are shown in the table 1. In the design of buildings and structures, a regional basic wind speed having a mean return period of 50 years shall be used except as specified in the note of table 1. This is the table 1. K1 factor, 50 years return period. If it is important structures like hospitals, communication towers, power plant structures, it is high. So what is K1 value? For 15 meters, the eaves board height is 15 meters, so it is 1.09. I'll show you Arjun by category 1. Exposed open terrain with few or no obstructions and in which the average height of any object surrounding the structure is less than 1.5 meter. The equivalent aerodynamic roughness coefficient for this terrain is 0.002. Typically, this category represents open sea coasts and flat plains without trees. Because I told you that this is on the hillock and near sea coast, I am taking this as 1.09. Did you understand? The eaves board height is 15 meters. If it is 10 meters, it is 1.05. If it is 20, it is 1.12. That is a height from the ground. Okay? Hello?
Yes, sir.
Okay. That is K2 value. Okay, oh, sorry. Sorry, I'm telling you about K1, no? Sorry, I went for the K2 also. This is K2, Baba. This is K2. This is K1 is 1. For 50 meters return period, it is This is close. You look at class 6.3.2 on table 2. K2 value is 1.09. Hope you are noting down.
Yes, sir.
Look at these clauses. What is the K3 formula given in the code? Please look at that. Look at this topographic vector K3. C value depends on the slope. Could you see your code book with you? Hello.
Yes, sir.
Can I get theta? 1 in 5. Tan inverse of 1 by 5. What is the value of theta?
$11.30.
Yeah, for 11.3. So it is theta greater than 3 and less than the 17 degrees. C value is given by 1.2 Z by L. See here, Z and L values are defined here. The wind is like this. The slope is 1 in 5, and if the height is 350 meters, and the length will be. Is it correct? Because the wind direction is reversible, then we will take this also as same thing. If it is different, we will calculate that as differently. Can you calculate the H value? Can you interpolate H value? This is 350 at 200 meters. We have the proposed structure. To the bottom of this is unit by H. Can you calculate H, Baba?
$310.
Yeah. Look at this here, Baba. Theta is within this range, thus LE, effective horizontal length of the hill, is equal to L. If it is theta is more than 17 degrees, then it is different, Z by 0.3. Did you note it down? Class C1, Annexure C1. Are you noting down, Baba? Hello.
Yes, sir.
Look at this. Ours is downward slope greater than 3 degrees. Hill and ridge. Should be table, it should be figure 14, Baba. Hello, look at this, Baba. Hello. X by LE 0.114 here. And then H by LE 0.18. Not figure 15, Baba, it is figure 14. You don't have to memorize these things. It is there in the code. You have to take that. Importance factor for cyclonic region. It is for industrial structures, it is 1.15. Are you looking at this code? That's why I'm displaying that. Hello? Hello, Babu.
Yes, sir.
Yes, sir.
Because it's industrial building, it is 1.15. If it is a regular building, it is 1. If post-cyclonic importance like hospitals, schools, it should be still higher, 1.3. Once K1, K2, K3, K4 are there, can you find out design wind speed? This one, class 6.3, design wind speed VZ. Hello? At a height
Yes,
H,
Yes, sir.
that is meters per second. Substitute and tell me VZ value. Please do this web up to this. I'll come back in 2 minutes. Did anybody calculate this, Baba? Just another 10-15 minutes on. 10 minutes on, I'll complete.
Three three four 8.054.
Yeah. You should look at the units also. ఇంత లేట్గా జాయిన్ అవుతున్నారప్ప. So this we have calculated. This is Newton per meter square. Vz is in meters per second. Then PD, design and pressure, is equal to KD, KA, KC, PZ. Should not be less than 0.7 PZ. I'm discussing about area averaging factor KA. This is the table 4 for this. This is nothing but the span. 5 meters is the center to center of the trusses, and the span is individual panel dimension, that is 20 meters, so it is 100 square meters. So from this table 4, it is more than or equal to 100. Area averaging factor is Ka is 0.8. Hope all of you are observing what I am showing in the code.
Yes, sir.
KD is the wind directionality factor. For cyclonic factors, it is 1. Otherwise, it is 0.9. And for circular and near circular forms, this factor is taken as 1. Then we have to find out the value of Kc. We want to show you the Kc value. Yeah, sorry. When taking wind loads on frames or clad buildings, it is reasonable to assume that the pressure or sections inside and outside the structure shall not fully correlated. Therefore, when taking the combined effect of wind loads on the frame, the reduction factor of zero point 0.9 may be used for the building envelope when the roof is subjected to pressure and internal pressure is suction or vice versa. So hence that's why I taken this zero point 0.9. Therefore, the design and pressure PD is equal to, what is the formula PD? In the beginning I explained KA, KA, KD, KC, PZ. This is what is to be found out. Once this is obtained, we will obtain the wind load CPE minus CPI into A into Z. Sorry, PD. Design pressure. This is what we are calculating. I'll go through that once again for the benefit of the people who joined little late, and also, did you note it down? Just 5 minutes and I will stop. Hello?
Yes, sir.
Yes, sir.
See, he has given this building some 65 meters. If the spacing of trusses is not given, please assume it as 5 meters approximately. And if the span is also not given, take it as 20. Okay, what we have to calculate in the problem PD, that is the design and pressure PD, because that is required for this to find out the forces on the individual members, external pressure minus internal pressure into surface area into design and pressure. And then in that KA, KC, KD, sorry, you write first KD because area averaging factor, directionality coefficient, and then combination factor into PZ. So PZ is equal to 0.6 VZ square. VZ is equal to VB into K1 into K2 K into K3, K4. Basic wind speed is given. Calculate the K1 value. Hope you noted down the clauses, Baba.
Yes, sir.
Yeah, then terrain roughness coefficient and height factor both, depending on the height. From the table 2, I showed you how to get the K2 value, and then topographic factor is given by this formula which is there in the annexure, and from the given slope of 1 in 5 we calculate theta, based on theta we have calculated the factor C, based on the height Z, H is the height of the building from the reference point, and then we have calculated the LE, then H by LE and X by LE, and from that figure 14 the factor S0 has been obtained, and hence K3 is obtained. K4 cyclonic factor, and hence design and speed is obtained. VB into K1, K2, K3, K4. And wind pressure is equal to Pz is equal to P6.6 Vz square. Then design wind pressure is equal to Ka, Kd, Kc, Pz. Then it is area averaging factor, and for this the tributary area is center to center distance between frames and individual panel dimension. So 100 meters square. For that Ka is equal to 0.8. Wind directionality factor, Kd is equal to 1. Just now I showed you this for cyclonic region. Sorry. And combination factor Kd, Kc is equal to 0.9 from this clause. Therefore, design pressure is Ka, Kd, Kc into Pz. Okay. Once this is obtained, if the CPI and CPE values are given, then we'll find out the values of F, and those things will be denoted on the as the nodal values on the joints of the roof truss. Okay. The study up to this and try to answer the first things. I hope all of you are going to carry the mini drafter, pencil, scale, eraser, apart from the pen, calculator, and code book size 800, steel tables, and also IS 875 part 3. These three things are allowed. If it is in the end exam, because those who are writing outside also, if it is not allowed, please request the invigilator to ask us. We can tell them to ask the teachers whether these code books are not allowed, whether they are allowed or not. Okay?
Yes.
Yes, sir.
Okay. At least you understand. Do it once again, just that will be good enough. Go through it. We have to find out PZ Baba. In the nutshell, I showed you what is to be done first. This is the roof truss on the hillock. Then we have to find out this design and pressure. That is formula is given in the code book. This is also given in the code book. All these three. Then we should understand those terminology. Then we have to find out the various factors depending on the slope. Then we can find out the PD value and VZ, PZ and PD value. This is what is to be found out. To find out the force in the members, CPE minus CPI into A divided by PD.
Sir,
Tell me, ma'am.
is the paper pattern same like RCC?
Same, Amma. Same. That's what I was telling you. One question is compulsory out of two. You have to do the design and drawing. And another is either 5, you have to answer 3. Am I correct?
Yes.
A similar pattern will be there, Amma, here also.
Okay, sir.
Say in the last minute, don't rush. Whatever you have studied, you study that thoroughly. And if you study that gantry girder, one question is compulsory, you'll get that. Usually, and tension compression members also you have studied, beams you have studied. Choice is only for writing the exam, not for preparation. Okay, so whatever you studied, please revise them and study well. Please do carry mini drafter, scale, pencil, eraser, calculator, IS-800 steel tables, and IS-875 part 3. And don't include any papers in the code book, Baba, please. Other than the things published by the Bureau of Indian Standards. Okay? Otherwise, you book it under malpractice. If somebody keeps them and says that I don't know, sir, means they also don't know except booking under malpractice. Okay, Baba. Thank you for your cooperation also. Because I was sick for some time because I got corona at the time. I could not complete in time. Okay. Okay, all the best, everyone.
Thank you, sir.
Thank you, sir.
Thank you. Good night. So carry all those things. Okay.
Yes, sir.
Yes.
Okay. Thank you. Good night.